How's it going, everybody? In this video, we're going to be taking a look at our next topic when it comes to FlexVPN, which is going to be auto encapsulation or auto detection of the remote end. Because there could be scenarios where you might have a variety of different solutions in play, or you don't. Regardless of the scenario, if you don't care about hard coding or want to worry about hard coding, and making sure that all of your VPN connections are of the same type, the easiest way to do that would be to go in and set the hub side to, on the virtual template, to be of mode auto. Now when you do that, you're basically going to accept in any type of connection, that'll be either GRE over IPsec, raw IPsec IPv4, or both. Now, what's cool about that is when you do that, you can also accept connections from ASAs on the dVTI, where normally if you're running something like dVPN with GRE over IPsec, you wouldn't be able to do that. So that's why when we talk about getting this stuff up and running, it's actually really advantageous for us to go in and enable capabilities like this so we can actually spin up connections from the ASA to CSR3 or CSR2. So we're going to go in and get the connection squared away on CSR2 and get him squared away. And then we're going to make sure that ASA1, or I'm sorry, then we're going to flip over CSR4 to be tunnel mode IPsec IPv4, because right now it's GRE over IPsec. And then what we're going to go do is then we're going to play around with ASA with a crypto map, and then we're going to go to the VTI variation. And depending on the time, I might convert everyone back over to BGP, so iBGP, so that every one of the sites will have reachability to all of the other sites. So let's go ahead and take a look at exactly how this will work. I'm going to go ahead and pull up the topology. Let me go ahead and open up router 5 and router 6 respectively and get them squared away. So let me go ahead and just move ASA1 here to the end. So what I'm going to go do is on CSR2, since right now he is our current hub for this, because we've already covered doing dual hub single cloud. So one of the things that I want to cover is adding ASA to the mix, because we haven't covered that yet. Right now we've just been using iOS routers. So if we were to do show run section IP2, if we come down underneath here, underneath the dVTI or the IP2 profile, you'll notice that I've added in this virtual template 100 mode auto. I'm actually going to go in and turn that off real quick. And I'm going to come in here and turn this off, right? Do show run section IKEv2. And you'll see that I've turned off, actually to remove the virtual template. So what I need to go do is come back in here and type this command in here. So now we're going to have the dVTI back on. But one of the options that we can do is type in mode and auto. So basically what will end up happening is, regardless of what the remote end is configured to do, the dVTI will say, you know what, I really don't care. If you're GRE over IPsec, or if you're IPsec IPv4 or a crypto map, go ahead, form a peering with me. So we do that, and by doing that, what will end up happening is it actually gives you a warning. It says mode auto takes precedence over the configured mode of the virtual template. That's fine. That's what we want it to do. So first thing I want to go do is on CSR4, I'm going to go to global config. After I look at show run interface tunnel 43, right now we're doing GRE over IPsec. So if I wanted to switch this over to IPsec IPv4, interface tunnel 43, and type in tunnel mode is IPsec IPv4, and you'll see that as soon as I do that, we get a bunch of information going back and forth, and then it forms an EIGRP adjacency. So we didn't have to do anything. It automatically did that for us, which is really, really cool. The next thing we're going to do is jump over to, we'll look at CSR2 from this perspective, and we'll see that our connection's up. So if we do show crypto IP2 SA, we can see that 4 is now up, And if we do a show crypto IPsec SA, and we look at pipe include peer, PKTS, and ident, you're going to see that for these connections, right now is bringing in it must have negotiated 40 GRE over IPsec for CSR4. So let's go flap that link real quick. Let's go shut it down. And then we're going to no shut it to bring it back online. So once that comes back online, and that's actually a good sign because now I know it's renegotiating. It might take it a couple seconds for it to trigger because we're using a client and it's not the quickest game in town. But basically, if we do this again, we'll see that we, still negotiating GRE over IPsec. Oh, there it goes. So let's see if that changed at all on CSR2. Because it should come in as raw IPsec. If we do a show crypto IP2 SA, and we come in and we look at the connection on CSR4 side, we do a show crypto IPsec SA. We are, see on this side here it's negotiating raw IP, or raw IPsec. On this side here it is actually not doing that. It's negotiating GRE over IPsec. Not sure exactly why it's doing that. Maybe I just need to clear crypto IP2 SA. Let's just do a hard clear and bring everything down and see if this will help resolve the issue. Because that might be the what's needed. I might have to bounce the tunnel on CSR2 side. But what should end up happening is after this comes back on CSR2 side, we should read this in as this stuff should come back online. Oh, you know what? It went over to CSR3. That's what ended up happening. Because we, in a previous video, we actually went through and set up failover. So that's actually what's happening here. So 5 and 6 peer to CSR3. Let me go ahead and move this guy over here to that side. Yep, so let me go to CSR3 and show run section crypto. This guy's configured for it as well. So let's go to 4 and show crypto IP, let's see what CSR3 is configured as. Show crypto IP2 SA and show crypto IPsec SA type include peer, ident, and PKTS. Okay, that's what I was expecting right here. This is negotiating it correctly. So we see that this one's doing raw IPsec, right? And that's exactly what I want to see. So that's basically how that would come into play. And that's a good sign because now I know it's doing IPsec IPv4, where 5 and 6 are doing GRE over IPsec. Okay. Now if we go to look at ASA, let's go ahead and look at this. If we look at the show run crypto, we already have the crypto in play from previous videos. We went through, we played around, we got the IP2 policy, because we did this in the beginning, right? We set up the ASA to do crypto map IP2, and then we even did a VTI tunnel to CSR3 and stuff like that. So all of that stuff should be still running. So we have the crypto map configured, we have it pointing towards CSR2 and all that good stuff. So all I'm going to have to do is, from the operations perspective, is go to CSR8. Let me come in here and do a show IP route VRF S11. Sorry, S11. We can see we have a default route. So let's go ahead and ping VRF S11 to 172.16.1.2 and ping. Let's see if this will actually trigger. Okay, it does trigger. We go over to ASA 1, show crypto IP2 SA, we have an active SA. We do a show crypto IPsec SA. We have an SA going across, and we can see that it's raw IPsec. Even though the entries on this side go over, if we look at CSR2, we can do a show crypto IP2 SA. We only have one connection up, and that's to ASA1. If we do a show crypto IPsec SA, because the fact that there is no entry on, there's no ACL on CSR2 side, or there's no crypto map. If we were to do a show run interface gig 1, there's no crypto map, right? So what's happening is, because of the information that we're receiving from ASA1, we are taking the information that ASA1 sent to us and then injecting it inside of the local identity and the remote identity. So we're populating the fields as we need to. So if I was to do the same thing and point myself towards CSR3, a show run crypto, I could come in here and show run tunnel group. I have a tunnel group to CSR3 previously. If I do the more system running config pipe begin tunnel group, we're going to see right here that ASA1 is the local pre-shared key, CSR3 says it's the remote. If I look at CSR3, show run section IKEv2, I have underneath the dVPN config, I already have all this populated. The only thing I have to do underneath here is go to the dVTI, underneath the, I'm sorry, not the dVTI, but underneath the profile, and say match identity remote address of 11.0.0.11/32, or any address really. I could have just populated with any, and that would have been sufficient too. But now that I've done it, now what I'll get to go do is I will have to go and create another entry in the crypto map. So the crypto map here, show run crypto, at the very top here, I'll go up to this guy and I will say crypto map, IP2 map, and then 20, and I'll say match address this guy. I will say crypto map 20, set the peer to be 31.0.0.3, and then this guy right here, crypto map 20, set IP2 proposal, I'm sorry, IPsec proposal, and then it's already enabled on the outside. So if I show run crypto, I've got those two entries now squared away. So now, theoretically speaking, if I was to go to plug in 3, for example, this is going to look like it's going to fail. But I look at, and I'm not surprised that it did. So if I look at the show crypto IKEv2 SA, and I look at CSR3, show crypto IKEv2 SA, I don't see an additional connection coming in. Now, that's not that big of a deal. But in this case here, I would need to do something in order to differentiate the communication, right? So what I'll do is I will, in most cases here, the configuration that's on CSR2 will be more than sufficient, but this one here will be the priority match because it's got a higher priority value. So normally what would end up happening is dead peer detection would kick in. This one here would get detected as down, and therefore I would send traffic to CSR3 instead. That's how that would come into play. So what I need to go and do, and then I'm not terribly worried about this, that's why I'm not really freaking out about it, is we can see the crypto map works, right? There's no doubt about that. The crypto map works, we saw it, inherit it. But I prefer a different type of scenario where we use a VTI tunnel. So we're on the version of code that supports it. We're on 991. 971 is when the tunnel config was available. So if we were to do change the config up and point this guy to be going towards CSR3, So let's do this. We're going to say interface tunnel. We're going to say 13. We'll type in tunnel destination is going to be 31.0.0.3. Tunnel source is going to be gig 0/0. Or actually, I'm sorry, this will be interface and it'll be outside. The tunnel mode will be IPsec IPv4. And we'll specify the tunnel protection will be IPsec profile, actually show run crypto IPsec. We do have a profile, so tunnel protection IPsec profile, and the profile name will be this guy right there. And then we're going to give it an IP address of, in this case here, CSR. I don't know if I can do negotiated. Yeah, I don't think that'll work because it's not really leveraging the same mechanisms that the routers will. So I'll have to give it an address. So 10.1. I don't know, let's say 100.100/24. I'll give it a name if of IKEv2 underscore VPN. And that will be all she wrote. So show interface IP brief. It's down. We'll no shut the tunnel. So interface tunnel 13. No shut it. Give it a new IP. And if we do a show interface IP brief, it's up, which is a good sign. Now CSR3 comes over here. It pops up. We get a line protocol for that guy. And now we have 11.0.0.1 pops up on dVTI. If we do a show IP interface brief, we can see that we have virtual access 1 popped up and show IP route, sorry, static. We can see that it's actually not showing up in the routing table, which is not surprising because of the fact of the nature of what we just did. But from a routing perspective, if we do a show route, we can point traffic out towards that network. So we can say route, and we're going to say IKEv2 VPN. And we can specify the prefix that we want to send towards. So we can type in 172.16.1.0/24 out towards the next hop of CSR3, which in this case here will be 100.3. We'll do that. And then we'll do the other one where we'll say 10.1.0.0/16, like so, and show run router EIGRP. So we are redistributing that into to EIGRP. So we hit the up arrow here, show IP route. Now we're getting those prefixes in play, and if I do that same ping again, oh, you know what? I need to propagate those routes. On CSR3, I need to show IP route down to over that connection. So one thing that you can't do on the ASA, or at least not definitively, there's no IKEv2, crypto IKEv2. There's no authorization policy here, so I can't actually go and send traffic over to the hub. So what I would need to do instead is on CSR3 is I would need to say, instead of learning, for example, the 10.8.11 network, I'd have to type in let's see here, show crypto IKEv2 SA, show IP interface brief, show IP route static. I should be able to ping 10.1.100. So let's ping 10.1.100.3. Yeah, see, this is the only drawback to this setup, is it makes it a little bit more complicated to work with. So normally I would not do a dVTI. Actually, the times I play with it, it's always been a little tricky to get it to work. I don't actually have a do 1, 2, 3, 4, 5, and boom, you're good to go. So in this case here, I don't have a way of really triggering this that I'm aware of. So interface tunnel 13. Let's show crypto IKEv2 SA. So I am paired with this guy, and show crypto IPsec SA. So I'm sending traffic towards let's do pipe include PKTS, peer, and ident. So I'm definitely sending traffic over the wire. There's definitely data going across for 3. Let's see if it'll give me any feedback as to the SA and the detailed. Let's see. There's really no information here that'll help me determine what's actually happening. So it's up, it's just not passing traffic. And that's the part that show run interface tunnel 13. Show IP interface brief. Oh, that's right. I'm not using a tunnel on this side. Which one did it bring up? Was it? Virtual access 1. Show IP route. There should be something in here. Nothing. Okay. There's usually some address that's brought over, and usually that's where this static route comes into play. There's usually some address that it points to so that I can jump across the connection to the other side. But in this case here, there isn't, which is what makes this a little more tricky to work with. Usually I don't use a dVTI tunnel. Or I'm sorry, normally I don't use svTI. I normally use, we know the crypto map variation is working, so we'll go with that. But I'll work on trying to figure out the static VTI tunnel connection on the ASA to a dVTI. The crypto map portion works. Once I figure out the svTI, I'll bring you guys back in. But with that being said, ladies and gentlemen, thanks so much for stopping by and hanging out with me. Take it easy.